today we'll go over some practice problems for pulleys and inclined planes. Starting out, consider the pulley system in the diagram below. What is the acceleration of the system, and what is the tension in the rope? Let us start by labeling the masses. This 10 kilogram one can be mass 1, and the 15 kilogram one can be mass 2. Now to find the acceleration, we can use Newton's second law, which says that the force is equal to the mass times the acceleration. Now, we'll have to use the net force on the system and the net mass of the system to find this. The net forces is just going to be the force of gravity from mass 2 minus the force of gravity on the 10 kilogram one. So, writing this out, we have the force is equal to force of gravity on the second mass minus the force of gravity on the first mass. And this is just equal to second mass times the acceleration due to gravity minus the first mass times the acceleration due to gravity. Now plugging in the values, we got that this is equal to 15 kilograms times it by 9.81 meters a second squared minus 10 kilograms times it by 9.81 meters a second squared. And this is equal to 49.05 newtons. Now to find the net mass of the system, we just need to add the masses together. So this will be mass 2 plus mass 1, which is equal to 10 kilograms plus 15 kilograms, which equals 25 kilograms. Now, let's use the F equals ma equation to solve for acceleration. Rearranging this, see that the force divided by the mass equals acceleration. So plugging in the values we got 49.05 newtons divided by 25 kilograms equals the acceleration. And this is equal to 1.96 meters a second squared. Now let us calculate the force of tension in the rope. Let's first consider the direction of each mass's acceleration. Mass 2 will accelerate downwards, and mass 1 will accelerate upwards because it is lighter than mass 2. Now to calculate the force of tension, we can look at either mass and the forces acting on it. So let's look at mass 1. You see that the net forces on mass 1 is the force of tension. Since it's moving upwards, it will be positive due to the acceleration going upwards, minus the force of gravity, which acts in the opposite direction of the force of tension in this case. So we can rearrange this formula to solve for the force of tension. We get that the force of tension is equal to the net force on mass 1 plus the force of gravity. So this means that the force of tension given by Newton's first law, we know that the net force is ma and gravity is mg. So the force of tension is equal to mass 1 times the acceleration plus mass 1 times gravity. This means that the force of tension is then equal to 10 kilograms times it by 1.96 meters a second squared plus 10 kilograms times it by 9.81 meters a second squared, which is equal to 117.7 newtons. For this next question, a 20 kilogram block is placed on a 40-degree inclined plane. The coefficient of static friction is 0.4 and the coefficient of kinetic friction is 0.3. Determine if the block will slide and find the acceleration of the block. In order for the block to slide, we need that the force of gravity is greater than the force of static friction. Let's start by drawing a free body diagram. So here's the block. Now, the normal force will be pointing opposite to the surface. The force of gravity will be trying to pull it down the slope. And the force of friction is acting opposite to the force of gravity. Now, we also know that the y component of the force of gravity is equal to the mass times gravity pulling straight down. Now, if we extend the normal force, or project it to this side, we can set up a triangle to calculate for the normal force, knowing that this angle is 40 degrees. So this means that the normal force is just equal to mg cosine of 40. And then the force of gravity is perpendicular to the normal force. So the force of gravity, in this case, is just equal to mg sine of 40 because it's perpendicular, and sine is perpendicular to cos. So let's calculate these. This means that normal force is equal to 20 kilograms times it by 9.81 meters a second squared multiplied by the cosine of 40 degrees. And this is equal to about 150.3 newtons. Now, the force of gravity is equal to 20 kilograms times it by 9.81 meters a second squared times it by sine of 40. This is equal to about 126.1 newtons. So now we need to solve for the force of static friction. The force of friction is equal to the coefficient of friction times it by the normal force. So the force of static friction equals the coefficient of static friction times the normal force. So in this case, that means it's equal to 0.4 times it by the normal force, so 150.3 newtons. which is equal to 60.1 newtons. And we see that the force of gravity is greater than the friction force, or static friction force. So, force of gravity greater than the force of static friction. Therefore, the block will slide. Now for the second part. Let's determine the acceleration of the block. For this part, we'll be using the coefficient of kinetic friction, since we know that the block will be moving. Now, in order to do so, we need to calculate the force of kinetic friction, which is equal to the coefficient of kinetic friction multiplied by normal force. So this is equal to 0.3 multiplied by 150.3 newtons. And this is equal to 45.9 newtons. Sorry, 45.09, so I'll round up to 45.1. Now, the net force is going to be equal to the force of gravity minus the force of kinetic friction when the block is moving. So this means that the net force is going to be equal to 126.1 newtons minus 45.1 newtons. Which equals 81 newtons. Now, we can use Newton's second law that says the force equals the mass times the acceleration. Rearranging it, solve for the acceleration, which means that the acceleration is equal to the net force divided by the mass. So plug in the values that we have for the net force. We get 81 newtons divided by 20 kilograms equals the acceleration. Since all of our values are in the SI units, we'll get the SI units of acceleration. So we got our answer of 4.05 meters second squared is the acceleration of the block. For this next problem, a 10-kilogram box is suspended in the air by a rope on a pulley attached to a 20-kilogram box at rest on a frictionless surface horizontal to the pulley. What is the acceleration of the system? What is the tension in the rope? So we can find the acceleration in the system by using Newton's second law that says force is equal to the mass times acceleration. Now the net force on the system is just going to be the force of gravity acting on the 10-kilogram box, because the 20-kilogram box is on a frictionless surface. So, to calculate the force of gravity, it's just simply, let's label this mass 1, and this will be mass 2. It'll be mass 1 times acceleration due to gravity, which is equal to 10 kilograms multiplied by 9.81 meters a second squared, equaling 98.1 newtons. But now, for the mass, we need to take the total mass of the system. So, mass is equal to mass 1 plus mass 2. equals 10 kilograms plus 20 kilograms, equaling 30 kilograms. Now, we can use the F equals ma equation to solve for acceleration. So this gives us 98.1 newtons divided by 30 kilograms. Which means that it'll accelerate at 3.27 meters a second squared. Now, to calculate the tension in the rope, the easiest way to do this is to use the forces acting on the second mass. Because it's on a frictionless horizontal surface, that means that there will only be the force of tension acting on it, since the force of gravity and the normal force will cancel out on the surface. So that means the net force on mass 2 is equal to the force of tension. Which means that the net force is given by F equals ma. So m2 times the acceleration is just equal to the force of tension. Plugging in the values, this means that 20 kilograms multiplied by 3.27 meters a second squared equals the force of tension. Which is equal to 65.4 newtons. For this last example, a 10 kilogram box is on a frictionless inclined plane of 30 degrees connected to a 20 kilogram box hanging vertically by a rope and pulley. What is the acceleration of the system? Let's start by labeling the 10 kilogram box as mass 1. A 20 kilogram box can be mass 2. Now, we'll use Newton's second law, F equals ma, to solve for this. But we need to find the net force on the system and the net mass. So the net force is going to be the force of gravity of the 20 kilogram, or mass 2, minus the force of gravity from the 10 kilogram box, or mass 1. So this is just equal to mass 2 times by gravity. And if you recall from the other example, the force of gravity for the box of the inclined plane will be mg times by the sine of this angle, which is 30 degrees. So, of mass 1 times by gravity times it by sine of 30 degrees. So this is equal to 20 kilograms times it by 9.81 meters a second squared minus 10 kilograms times it by 9.81 meters a second squared times by sine 30. So calculating these values, we get that the total net force is equal to 147.2 newtons. Now, you might notice that this value for the net force is positive. That's because we subtracted the force of gravity from mass 1 from mass 2, meaning that force of gravity for mass 2 is greater than the force of gravity for mass 1. So the acceleration will be down, or in the direction of mass 2. If we got this answer as negative, that means that mass 1 would have a greater force of gravity on it than mass 2, and it would instead accelerate down the ramp. Now, let's calculate the value of the acceleration. To do so, we still need to find the total mass of the system, which is just equal to mass 1 plus mass 2, which is then equal to 10 kilograms plus 20 kilograms, equaling 30 kilograms. Now, using Newton's second law, we rearrange this, and we get force divided by mass is equal to the acceleration. So plug in the values. We have 147 newtons, 147.2, divided by 30 kilograms, which equals the acceleration. And calculating this value, we get that the acceleration is equal to 4.91 meters second squared. And the direction will be down for mass 2, or mass 1 will be going up the ramp.